is Never Been Juni, and I would like to start our video presentation. So we are given we need to design represent a significant advance in medical technology. So we are given set of components which is processor board, LCD, ECG module, and also Bluetooth module. We need to design one casing that can accommodate all the set of components. We need to consider all the components remain secure and well organized. The dimension of each component is in millimeter. We also need to consider that the design had a good air ventilation. For the reason is all the components are not overheating.
Hi, my name is Nur Farisha binti Roslan. My metric number is 221151532 and this is the design draft, which is the first draft of the design from my group. I'm going to begin with the measurement of the design that I have made and then the other details of the design. The measurement of the design is about 10 centimeters in length and 10 centimeters width. It has a square shape which has 90 degrees in each side of corner. Next, the width of my design is 6 centimeters of the top and bottom part of the case. For my design, I decided to go for a convenient, simple and modern design. The design has a holder which makes it easier to bring along whenever it needs to be. I designed the holder that has a hand grip design, so it greatly helps to decrease risk factors associated with tool use and decrease risk of injury. Even the hand grip design will cost a bit at manufacturing cost and time along, but when concept of my design is convenience, I try to design a good case that have advantages for it. For the top part of the case, a hole measuring 7.05 centimeters in length and 4.33 centimeters in width is made to fit the LCD TFT 2.4 screen, and 4 screw holes were made on the top of the case which is aligned to the LCD screen outer part to fit the LCD screen to the top of the case. Now let's move on to the body part of the case. There is a multiple screw holes of different sizes were made on the bottom side of the kit, which correspond to the holes of the Arduino Uno processor board and AD8232 ECG module, with a little bit space between each component so it will look neat and simple. As you can see, I have created a slot on the inside of the body to fit the Bluetooth module, which is necessary due to the component that doesn't have a screw hole or something to hold on the component on the case. Next, there is a 3 slot on the side of the case was made to put the component for the Arduino and for the AD8232 module. Its output to connect with an electrode 3 lead. Other than that, there is a 4 holes were made on the 4 edges of the case to fit and combine them together. I have designed the edge of the case with fillet and chamfer so it will look sleek and not harmful to use. That's complete my explanation of my design. Thank you.
Hi, my name is Wan Muhammad Nur Tasnim bin Wan Muhammad Zaki. This is my design for the draft 2. Okay, I use Inventor to complete my design. Basically, my design I created two component, which is the bottom and the top part. Then I fillet all the corners to make it not sharp. Then I assemble it to be one component. I make it simple because it will help us to cut some cost and it will be cheap. Okay, for the front view, you can see that I make hole to place the LCD module. So we can screw the LCD, that 4 hole, we can screw that LCD to make it doesn't move. Okay, for the right view, you can see there are 3 holes, which is 2 of them to place the Arduino Uno. We make some space between Arduino and the ECG module. So between them, I make some 5 cm space. In the isometric view, you can see that a slot in the box. I make slot to the Bluetooth, so it will doesn't move. Okay. For the design, I make it standing ECG monitoring system because it will make it easily to us to see the result that we observe. I think that's all for me. Thank you.
Hello, my name is Ahmad Ihab bin Muhammad Adeli, and this is the design draft, which is the third draft of the group. To start, I will be giving the measurement of the case made, and then the other details of the case. The case is 11.2 centimeters in length and 8.5 centimeter, and with the combined width of 3 cm of the top and bottom part of the case. For this design, I decided to go for a more simple and sleek look for the design. Thus, the design is quite modest with only the necessary addition and features. This helped cut down on costs, manufacturing costs, and time, along with easier troubleshooting if any problem arises due to the low point of failure, which is the product of the simple design. For the top part of the case, a hole measuring 5.05 centimeters in length and 4.33 centimeters in width is made to fit the LCD TFT 2.4-inch screen, and 4 screw holes were also made on the top of the case, which is aligned to the LCD screen outer part to fit the LCD screen to the top of the case. Due to the dimension of the LCD screen, an extrusion set is made to fit the screws. For the bottom part of the case, multiple screw holes of different sizes were made on top of the cylinder extrusion, which correspond to the holes of the Arduino Uno processor board and AD8232 ECG module, with sufficient space between each component to ensure no undesirable contacts happen. A slot on the bottom was also made to fit the HC05FC114 Bluetooth module, which is necessary due to the module lack of a screw hole. Next, holes on the side of the case was made to line up with the I/O of the two board. For the Arduino, it's USB and power output for the AD8232 module, its output to connect with an electrode 3 lead. Other than that, 4 holes were also made on the 4 edges of the case to fit and combine them together, and the edges of the outside of the case was rounded to make the handling the case safer and easier. Thus concludes my presentation of my design draft. Thank you.
This is our final design of the we choose. This is design number 3. Design number 3 is a chosen option due to its simplicity, cost effectiveness, clean aesthetic, compact components arrangement for robustness, and the ability to handle heat without the need for additional ventilation. These factors collectively contribute to a design that is both practical for manufacture and user-friendly. For material, we choose polyethylene terephthalate. Why we choose PET? There are many reasons why we choose PET. First of all, its durability. PET is a robust and long-lasting material that can be used to shield other products, such as electronic gadgets. It is impact resistant and won't shatter or crack. Secondly is cost effectiveness. PET is an affordable material for mass-produced goods since it is more affordable than some other materials. Next is transparency. PET appears translucent or semi-transparent because to its exceptional optical clarity. For products where aesthetic appeal or the ability to see what's within the casing is vital, this is design. Next is processing ease. PET is simple to process using standard industrial methods like injection molding. This helps explain why it's used so widely across many industries. Temperature resistant. PET is stable across a wide range of temperature. For situations where temperature swings are frequent, this is crucial. Last but not least, recyclability. PET can be recycled and many areas have a strong infrastructure in place for doing so. This is consistent with the increasing focus on ecologically friendly activities and sustainability.
Now I will discuss our group project material of choice, which is propylene terephthalate or known as PET. We chose this material because it is durable, lightweight, cost-effective, easy to process, and have good temperature resistance. Let us continue into the analysis of the ANSYS software for the model. In the ANSYS software, I have set a boundary condition of a force acting at the top and the front side of the model of 200.7 Newton. I also set a fixed support at the bottom of the model. Now let us go into the verification, which is the comparison between the calculated value from the pre-analysis and the measured value in ANSYS software. For equivalent stress at the top, I have calculated the value of 4.317 psi, and in measured value, I have calculated 1902.1 psi. At the front, the equivalent stress are 1.685 psi, and the measured value are 1620.3 psi. For the calculated value of equivalent elastic strength for the top and the front, I have calculated the value equivalent to 0 psi because the value are very small. And for the measured value, I have calculated for both of the top and the front 0.004 inches over inch in the ANSYS software.